Start. Alright. Okay, I'm going to solve this problem because of time we didn't manage to finish. So what we're going to do, since the standard format for linear function is saying y is equals to mx plus c. So it means we must have y here, we must have our x and its coefficient on the right side, and we have our constant here. So if I check our x and its gradient, it's on the left, so it must move to the right to look like this, and we have our c, our constant, but our constant is 12 now for sure. Our constant is already on the right, so it's a matter of rearrangement. What we're going to do, we're going to move this 3x to the right side. So we're going to say we're remaining with 2y this side, and if we move 3x to the other side, since it's positive, it will change sign to be negative 3x, and then we add our constant. So it must look more like the linear function standard format. So now we have our gradient, here is our negative 3, we have our x, here is our x, we have our constant which is c, we can see here is 12. So now it's rearranged, but we are not done because we don't want 2y. Actually we want y to be the subject of the formula. So what we're going to do, we'll divide by 2, and then here we're going to divide everything by 2 again, because what we do on the left, we must also do it on the right. So these 2 will cancel these 2, and then y is going to be, okay, if we have 2 terms separated by a sign, a plus or a minus, divided by a single denominator, we're going to split those terms, and then we're going to share these 2 individually, like negative 3x divided by 2 plus 12, it will be divided by 2. So this is simple primary division. And then what we're going to do, we're going to say negative 3 divided by 2. This is actually a fraction, it's going to give us a decimal. We're not going to do anything with it, so it will be negative 3 over 2x plus 12 divided by 2 is 6. So we have managed to rearrange this into this. So now this one, it looks more familiar with our standard format for linear function, because now we have our m as the coefficient of x, you can see our negative 3x as the coefficient of x, and then plus c, we can see we have our 6 here, which is our constant. So we can say this is our gradient, and we can say, see, this is our constant. But as I said, our constant is actually the y-intercept. So now, by looking at the graph, we didn't draw the graph, but by looking at the sign, look, our m, our gradient here is negative 3 over 2. Negative means what? Means decreasing. Meaning that if we are about to draw the graph will be decreasing like this, because our gradient is negative. If our gradient was positive, our graph was going to be increased like this in a slope as I indicated. So now I'm interested in seeing the graph of this one. So I would like us to solve this one. Actually, we draw the graph of y is equals to negative 3x plus 6. So firstly, I'll start by drawing a Cartesian plane here. Okay. So here, this is our origin. Everything is 0, 0. X is 0 and y is 0 here. But as we move, we're going positively here. On the right, what x now is becoming positive. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10, 11, up until to positive infinity. As we go to the left, now we're getting more smaller, we're getting more negative on the x-axis horizontally, up until negative infinity. And then horizontally, as we go up, we are increasing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we go down on the y-axis, we are actually decreasing. We are getting more smaller. We are getting more negative, as I explained in our slide. So before I draw the graph of y is equals to negative 3x plus 6, I want to explain why I'm saying that in this x-axis, y is 0 here throughout, and then yx is 0 here on y. Because let me give you an example. If you are here at this quadrant, let me call this quadrant 1, let me call this quadrant 2, let me call this quadrant 3, and let me call this quadrant 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if you are anywhere at this quadrant, the possibility of getting x and also getting y to be 0 is actually less, it's more impossible. You understand? Because you are not on top of one of the lines. You understand? For an example, let me give you a point. Let me give you a point here. Let me just say we have a point here. It's point A. We have point B. We have point C. We have point D. We have point E. We have point F. We have point G. Alright, I'll start by point A. If we want to find the coordinates here, the coordinates, they are always x and y, just like this. Even here we're going to have x and y coordinates. Here we're also going to have x and y coordinate. Here we're going to have x and y coordinate. E, we're going to have x and y coordinate. F, we're going to have also x and y coordinate. So coordinates are always written like this. So I'll start by A. A, I would like to check where is A located in terms of x. And then when I see here is our x, and if we want to go to x, we cannot go this way. If we go this way, we are reaching y. If we go this way, we are not going to touch anything. If we go this way, nothing are we going to touch or we are going to relate to. But the only way to find x at this point is when we try to look at x and we go straight to x. I find that according to x, this point, x is 7. And then according to y is here. So if I want to find the corresponding y, I must make sure that I reach this point. I find that y is 5. Now I come to point B. If I'm at this point, if I look for x, x is here, x is here. And then the way to get to x is to go straight to where there is x. For me, is to go straight to where there is x. I find that x is 4. Y, I go to y, I find that y is 1.5. Y is 1.5. I go to C. C, I want to find x in terms of C. Here is our x. The way to find x is to go straight to x. You see, when I go to x, when I reach here, that x is somewhere at negative 3.5. And then where is y? Y is here. The only way to find y is to go straight to where y. I find that my y is negative 2. Now I go to my D. D, I must look for x, but x is here. The only way to find x is to go straight to x. I find that x is, let me say, is -7. The only way to find what is this one? The only way to find is to go straight to y. And then when I check, y is -8. I go to E. E, where is x in terms of this point E? X is here. The only way to find x is to go down and meet x. X is at -4. And then y is here. The only way to find y at this point is to go straight to y. I find that y is -3. So this is how we're saying, if you are at this point, the possibility of finding 0 in one of the coordinates is actually 0. It's actually 0 because we find 0 only when we are moving on top of this line or on top of this line. So I want to show you why are we saying I want to talk about G now, and I want to also talk about F, and I want to show you why are we saying that in this line y in the x-axis y is y0, and when y in y-x is 0. Because now the same thing we did here, we are going to go to G. G is here on top of this x. And then what is x on top of this x? We are on top of x. X is 8. But what is y? Look at y. Y is here. The only way to find y is to go straight to y. Look, where are we touching y? We are touching y here at 0. That's why G, x is here at G at 8. But y, what is y? Y is 0. Even if we are here, if we go, as long as we are on top of the x-axis, when we want to find y, we are going to find y here. And then when we start going, want to find y, we are going to meet y at 0. So anywhere in this line, anywhere in the x-axis, y is 0. Same thing with the y. If you want to find x, x is here. X is here. X is here. This is the x-axis. So if we say y is 6, now we want to find x. What is x here? The only way to find x is to make sure that we approach this line. And then we approach this line. Where are we finding x? Look, we are meeting x here exactly at 0. If y is 6, x is 0. So meaning that even if we are here, even if we start from the roof there, as long as we are on the y-axis, we will meet x here. Even if we are down there on the floor, we start, as long as we are on top of the y-axis. If we want x, we are going to meet x here. We are going to meet x here at 0. So anywhere in this line of y, x is 0. Anywhere in this line x, this axis of x, y is 0. Here on y, x is 0. Here on x, y is 0. So this is what I was trying to explain. So why are we saying at intercepts? Why are we saying at y-intercept x is 0? Because here at this line x will always be 0. And then why are we saying here at x-intercept y is 0? Everywhere at this x-axis y will always be 0. And the intercepts, they happen on top of axis. So now I want to quickly solve this other question. So if you want to draw a graph from this function or this equation, firstly we will look for y-intercept. But we are saying that 6 is the constant and 6 is the y-intercept. Why did we come to a conclusion we say 6 is the y-intercept? Because when we are looking for y-intercept, we are on top of y. And if we are on top of y, x is 0. Look what is going to happen. Y is equals to -3/2. X at y-axis is 0. Everything here is 0. We are just left with 6. Everything here is 0 here. That's why we are saying that at C is our y-intercept, because everywhere in the y, x is 0. That's why everything is 0, we are left with the c. That's why we don't have to calculate, but it's necessary to calculate, but we already know that c, or our 6, is our y-intercept. We must always keep this in mind. If you didn't know why c is the y-intercept, it's because of this 0. When we put this 0, everything changes, we are left with the c. So that's why we are saying that our c is always the constant. So we found our y-intercept. But now, if you calculate, you easily say y-intercept. At y-intercept, what is happening? X is equals to 0. As I said, everywhere here on the y, x is 0. Everywhere in the y, you meet x at 0. And then now I go to the x-intercept. I'm done with y-intercept. Now I'm going to the x. I'm going to the x-intercept. X-intercept, what is happening at x-intercept? X-intercept, y is 0. Y is 0. We have talked about this. Spoke about this. Everywhere in the x, you meet y here at 0. Everywhere in the x, you meet y here at 0. Same thing here in the y, you meet x here. So you must know, guys, this is very simple. Everywhere at y, x is 0. Everywhere at x, y is 0. So now we solve for x-intercept. And then here, x-intercepts happen here on top of this line where y is 0. That's why we must put y 0 and we see where is the graph cutting the axis. And then we are going to say y is equals to negative 3 over 2x plus 6. So we want to find x-intercept, but y is 0. Y is 0. Negative 3 over 2x plus 6. I see negative here, and I see an opportunity of taking this one to this side to become positive. Then negative will change now. Look, it will no longer become negative 3 over 2. It will be 3 over 2. X is equals to 6. I don't want 3 over 2. I want x. So what I'm going to do, I'm going to multiply by 2 over 3. But since people are confused by this math, I'm saying I will multiply by 2. So that this 2 and this 2 will cancel, and I multiply by 2. And then 3x is equals to 12. And then what I'm going to do, I'm going to divide by 3. I'm going to divide by 3. This 3 will cancel with this 3 because I don't want 3x. I want 3. I want x. X is equals to, how many times 3 goes into 12? It goes 3 times. 3, 6, 9, 12. It goes 4 times. So now my y-intercept is 6 and my x-intercept is 4. Now I'm ready to draw my graph. Alright, what is my y-intercept? My y-intercept is 6. So where is y? Y positive. Y is positive here on top. So I cannot expect to have 6 here, because from this origin going down is negative. From this origin going to the left is negative. Positive, positive. So if I see positive 6 somewhere on top, let me say 1, 2, 3, 4, 5, 6. Let me say it's here. But what is x? I told you here in this line, everywhere in this line, x is 0. X is 0 here in this line. X is 0 and then y is 6. And then what is our x-intercept? Our x-intercept is 4. And then in terms of x, we cannot expect to have 4 here because this is the negative side. This is the positive side. 1, 2, 3, 4. Okay, our 4 is somewhere here. x is 4, but everywhere in this line, y, we meet y at 0. Y is 0. Alright, we have our y-intercept with our x-intercept. What we are left with is to just combine the points, and then we draw our graph. And then we are done with our graph. You can see the graph is decreasing. Why? Because our gradient is negative. As I told you, when the gradient is negative, our graph is decreasing. So now I want us to go back to find gradient and find equation of this graph. Let us say we are not given an equation, but we want to find back this equation. We want to find back this equation. We are given a graph. Let us say we don't have this equation, but we want to get back to this equation. What we're going to have, we want to find this equation. We are not given, but we are given a graph. But from this graph, we can get to the equation. We need to find m. We need to find c. X and y, they are always there. It can be any number. You can just put anything. They are ready there for any substitution. So you don't have to know them. You can know them if you want to substitute. We want to find a certain point. So now we don't want to find a certain point. We want to find the formula. We want to find the equation of the linear, meaning that we have to find y and we have to find c. Firstly, we're going to start by finding we're firstly going to start by finding m. We want to find m, and then we find c. We want to find m, and then m, as we spoke in the video, m is y2 minus y1 over x2 minus x1. So what is x2? What is x1? What is y2? Where is y1 here? You choose one point. If you say this one point is point 1, x here must be x1, y here must be y1, x here must be x2, y here must be y2. So if here x is at point 1, even this one must be at the same point 1. So you cannot have x at point 1 and then at that same point you have y at point 2. So you cannot have point 1 and 2 at the same point. No. X at point 1, y at point 1. X at point 2 and then y at point 2. So what is our y2? I see our y2 here being 6. What is our y1? I see our y1 here being 0. What is our x2? I see our x2 here being 0. What is our x1? I see our x1 here being 4. 6 minus 0 is 6. And then 0 minus 4 is negative 4. And then this gives us a negative 3 over 2. So this is our gradient. This is our m. Are we done? No, we are not done. We are left with c. So now we have y is equals to mx plus c. But now we have m. We can substitute our m here. Y is equals to, what is m? It's negative 3 over 2x plus c. We don't know c. But you see, I said c is the y-intercept, meaning that exactly c is the y-intercept is 6. But you cannot say it's 6. Prove that is 6. To prove that is 6, let us use one point. Let us use one point to prove that c is really 6. We can use this one. The y-intercept, you can use this one. The y-intercept, the y-intercept, you can use the y or the x. I prefer to use the x. I can use the y, anything I want. Let me use the x. If I use the x, it means I've taken this point 4 and 0, meaning that this is x and this is y. So I must use that point to substitute on y and x to find c. So what is y? I see y being 0. What is x? I see x being 4 plus c. And then when I check here, 0 is equals to negative 3 times 4 is negative 12 over 2 plus c. 0 is equals to, what is negative 12 divided by 2? It's negative 6 plus c. I don't want negative 6 plus c. I want c. So if I want c, I must push this 6 to the other side. And then this negative will become positive now. 6 is equals to c. So now 6 is equals to c. C is equals to 6. Meaning that I found my c is 6. And if we check, c is 6 here. And then c is 6 here as the y-intercept, we know. So now we are going to change now. Since we had gradient, we didn't know c. Now we know c. Our c is 6. So now we're going to write it as y is equals to m. What is our m? Our m is negative 3 over 2. Negative 3 over 2x plus, what is our c? Our c is 6. Then it is like this. So now we managed to come from the graph to the formula using these 2 points to calculate what? Gradient. So when we have calculated gradient, we use 1 point to substitute y and x to find c. So even if we have used 6, we're going to get the 6 here. If we used 0 and 6, we're still going to get the same answer. But I decided to use this one, and then still we got 6. So we must be able to use this equation to draw the graph. And if we have the graph, being able to use the graph to formulate the equation. So I think for today I'm done with the video. Then everyone must be able to use the equation to draw this equation to draw the graph. And then if you have the graph, erase the equation, use 2 points to calculate the gradient, and take 1 point to calculate your c, your intercept, and redraw your equation. Thank you very much.
Okay.